Isaac Newton was an English scientist, mathematician, physicist, astronomer, alchemist, theologian, and author who was described in his time as a natural philosopher. He was a key figure in the scientific revolution and the enlightenment that he brought into the world. Sir Isaac Newton contributed significantly to the field of science over his lifetime. He invented calculus and provided a clear understanding of optics. But his most significant work had to do with forces, specifically with the development of a universal law of gravitation and his laws of motion. Isaac Newton was born on Christmas Day, 25th of December 1642, according to the Julian calendar in use in England at the time. According to New System, on January the 4th of 1643, at Woolsthorpe Manor in Woolsthorpe by Colsterworth, a hamlet in the county of Lincolnshire. His father, also named Isaac Newton, had died 3 months before Newton was born. Born prematurely, Newton was a small child. His mother, Hannah Ayscough, once said that he could have fit inside a medium-sized mug. When Newton was 3, his mother remarried and went to live with her new husband, the Reverend Barnabas Smith, leaving her son in the care of his maternal grandmother, Marjorie Ayscough. From the age of about 12 until he was 17, Newton was educated at the King's School in Grantham, which taught Latin and ancient Greek, and learned a significant basic of mathematics. He was removed from school and returned to Woolsthorpe by Colsterworth by October 1659. His mother, widowed for the second time, attempted to make him a farmer, an occupation he hated. Henry Stokes, a master at the King's School, persuaded his mother to send him back to school. Soon he became the top-ranked student. He made sundials and models of windmills in the school by his own. In June 1661, Newton was admitted to Trinity College at the University of Cambridge. Newton studied a classical curriculum at Cambridge, but he became attracted by the works of modern philosophers such as René Descartes. Even devoting a set of notes to his outside readings he titled Questions Quaedam Philosophicae, meaning certain philosophic-al questions. When the Great Plague closed Cambridge in 1665, Newton returned home and began spending time on working on his theories on calculus and light and color. He did not know what he wanted to be or do, but it did not tend sheep or follow the plow in the dung cart, Brokeleg. While there, he took an interest in mathematics, optics, physics, and astronomy. Newton returned to Cambridge in 1667 and was elected a minor fellow. He constructed the first reflecting telescope in 1668, and the following year he received his Master of Arts degree and took over as Cambridge's Lucasian Professor of Mathematics. Asked to give a demonstration of his telescope to the Royal Society of London in 1671, he was elected to the Royal Society the following year and published his notes on optics for his peers. After his graduation, he began to teach at the college and was appointed as the second Lucasian chair there. Today, the chair is considered the most renowned academic chair in the world, held by the likes of Charles Babbage and Stephen Hawking. Through his experiments with refraction, Newton determined that white light was a composite of all the colors on the spectrum, and he asserted that light was composed of particles instead of waves. His methods drew sharp rebuke from established society member Robert Hooke, who was unsparing again with Newton's follow-up paper in 1675. In 1684, English astronomer Edmund Halley paid a visit to Newton. Upon learning that Newton had mathematically worked out the elliptical paths of celestial bodies like planets and stars and comets, Halley urged him to organize his notes. The result was the 1687 publication of Philosophiae Naturalis Principia Mathematica, Mathematical Principles of Natural Philosophy, which established the 3 laws of motion and the law of universal gravity. Newton's 3 laws of motion state that 1. Every object in a state of uniform motion will remain in that state of motion unless an external force acts on it. 2. Force equals mass times acceleration. F. Force equals m, mass multiplied by a acceleration. And 3. For every action there is an equal and opposite reaction. Popularity of Principia made Newton to stardom in intellectual circles, eventually earning universal acclaim as one of the most important works of modern science. From all of this, Newton calculated the universal law of gravitation. He found that as 2 bodies move farther away from one another, the gravitational attraction between them decreases by the reverse ratio of the square of the distance. Thus, if the objects are twice as far apart, the gravitational force is only 1/4 as strong. If they are 3 times as far apart, it is only a ninth of its previous power. These laws help scientists understand more about the motions of planets in the solar system and of the moon around Earth. A popular suspected story tells of an apple falling from a tree in Newton's garden, which brought Newton to an understanding of forces, particularly gravity. Whether the incident actually happened is unknown, but historians doubt the event, if it occurred, was the driving force in Newton's thought process. The myth tells of Isaac Newton having returned to his family farm in Woolsthorpe, escaping Cambridge for a short time, as it was dealing with a plague outbreak. As he sat in the farm's orchard, an apple fell from one of the trees. Some tellings it hit Newton on the head. Watching this happen, Newton began to consider the forces that meant the apple always fell directly towards the ground, beginning his examination of gravity. One of the reasons that this story gained a foothold in popular understanding is that it is an anecdote Newton himself seems to have shared. Toward the end of his life, Newton told the apple anecdote around 4 times, although it only became well known in the 19th century, wrote Patricia Farah, a historian of science at the University of Cambridge, in a chapter of Newton's apple and other myths about science. However, it would be only after 20 years before Newton published his theories on gravity. It seems that Newton used the story as a means of connecting the concept of gravity's impact on objects on Earth with its impact on objects in space for his contemporary audience. The apple tree in question, known as the Flower of Kent, still blooms in the orchard of Woolsthorpe Manor and is now a popular tourist attraction. In 1689, Newton was elected as a member of Parliament for the university. The death of Hooke in 1703 allowed Newton to take over as president of the Royal Society, and the following year he published his second major work, Optics. Composed largely from his earlier notes on the subject, the book detailed Newton's painstaking experiments with refraction and the color spectrum, closing with his ruminations on such matters as energy and electricity. In 1705, he was knighted by Queen Anne of England. It is widely popular and accepted fact that Newton never married and devoted his whole life in the discoveries, service, and finding facts in the field of science. Disturbed by the problems with telescopes at the time, he invented the reflecting telescope, grinding the mirror and building the tube himself. Relying on a mirror rather than lenses, the telescope presented a sharper image than refracting telescopes at the time. Modern techniques have reduced the problems caused by lenses, but large telescopes such as the James Webb Space Telescope use mirrors. As a student, Newton studied the most advanced mathematical texts of his time. He took exceptional efforts to study mathematics, laying the ground for differential and integral calculus. He united many techniques that had previously been considered separately, such as finding areas, tangents, and the lengths of curves. He wrote De Methodis Sidierum et Fluxionum in 1671, but was unable to find a publisher. Newton also established a cohesive scientific method to be used across disciplines. Previous explorations of science varied depending on the field. Newton established a set format for experimentation still used today. However, not all of Newton's ideas were quite as revolutionary. In Principia, Newton describes how rarefied vapor from comet tails is pulled into Earth's gravitational grasp and enables the movements of the planet's fluids along with the most subtle and useful part of our air, and so much required to sustain the life of all things with us. Some of his famous quotes are, "Plato is my friend, Aristotle is my friend, but my greatest friend is truth. Genius is patience. If I have seen further, it is by standing on the shoulders of giants. I see I have made myself a slave to philosophy. I do not know what I may appear to the world, but to myself I seem to have been only like a boy playing on the seashore, and diverting myself in now and then finding a smoother pebble or a prettier shell than ordinary, whilst the great ocean of truth lay all undiscovered before me. To any action there is always an opposite and equal reaction. In other words, the actions of two bodies upon each other are always equal and always opposite in direction. Truth is ever to be found in simplicity, and not in the multiplicity and confusion of things." Newton died on March 31, 1727, during his sleep at the age of 84, and was buried in Westminster Abbey. Although the cause of death is unknown, a 1979 study published by Newton's own Royal Society suggests mercury poisoning may have contributed to the decline of his physical and mental health. During the exhumation of his body, large amounts of mercury were found in the scientist's system, likely due to his work with alchemy. Newton conducted several experiments to convert base metals, such as mercury and copper, into precious metals, such as gold and silver. After his death, his body was moved to a more prominent place in Westminster Abbey. His white and gray marble monument stands in the Abbey's choir screen and boasts sculptures of Newton lounging surrounded by children using the many instruments, such as telescopes, associated with Newton's work. The inscription on the monument, originally written in Latin, reads, "Here is buried Isaac Newton, knight, who by a strength of mind almost divine, and mathematical principles peculiarly his own, explored the course and figures of the planets, the paths of comets, the tides of the sea, the dissimilarities in rays of light, and what no other scholar has previously imagined, the properties of the colors thus produced. Diligent, sagacious, and faithful in his expositions of nature, antiquity, and the Holy Scriptures, he vindicated by his philosophy the majesty of God mighty and good, and expressed the simplicity of the gospel in his manners. Mortals rejoice that there has existed such, and so great, an ornament of the human race, a giant even among the brilliant minds that drove the scientific revolution. Newton is remembered as a transformative scholar, inventor, and writer. He eradicated any doubts about the heliocentric model of the universe by establishing celestial mechanics, his precise methodology giving birth to what is known as the scientific method. Although his theories of space-time and gravity eventually gave way to future scientists like Albert Einstein, his work remains the base on which modern physics was built. Newton's monument can be seen in Westminster Abbey, at the north of the entrance to the choir against the choir screen, near his tomb. It was executed by the sculptor Michael Rysbrack in white and gray marble with design by the architect William Kent. From 1978 until 1988, an image of Newton designed by Harry Ecclestone appeared on Series D £1 banknotes issued by the Bank of England. Newton was shown on the reverse of the notes holding a book and accompanied by a telescope, a prism, and a map of the solar system. A statue of Isaac Newton, looking at an apple at his feet, can be seen at the Oxford University Museum of Natural History. A large bronze statue, Newton, after William Blake by Eduardo Paolozzi, dated 1995 and inspired by Blake's etching, dominates the piazza of the British Library in London. A bronze statue of Newton was erected in 1858 in the center of Grantham, where he went to school, prominently standing in front of Grantham Guildhall. The still surviving farmhouse at Woolsthorpe by Colsterworth is a Grade I listed building by Historic England through being his birthplace, and where he discovered gravity and developed his theories regarding the refraction of light. That's the amazing story of Sir Isaac Newton, the man who unlocked the secrets of gravity and changed the way we see the universe. So, if you could ask Sir Isaac Newton one question, what would it be? Would you want to know more about falling apples, the secrets of the cosmos, or maybe even his favorite scientific experiment? Let us know in the comments below. And if you learned something from the video, then please like, share, and subscribe for more such videos on lives of great personalities of the world.